please feel free to use the chat on your right hand to participate, ask any questions. And I think we can dive straight into and start our talk. So let's begin by sharing our presentation. Good morning, everyone, and thank you for joining us today. Today's talk is titled Thinking Like an Attacker, and is a review of some personality and context aspects of professional offensive cybersecurity professional individuals and teams. And, we will be focusing on API security, of course. My name is Sella Rafaeli. I am an American Israeli. I spent the last 15 years or so working on API security, first in the Israeli military at Unit 8200, which you might have heard of, possibly the strongest organization in the world in terms of cybersecurity. After the Army, I brought this experience into the private sector. And when I joined WIB, the company on whose behalf I am presenting today, it was a chance to formulate the years of knowledge and experience into processes and technology. WIB, in this aspect, is part of a global trend. As cybersecurity matures and evolves, your average attacker is no longer an individual script kiddie or a bored Linux developer. It is more often than not that it is a military or ex-military group or team that is experienced, motivated, and funded. As part of our work to help ensure our clients' API security, we often launch simulated API attacks on them, both to demonstrate the capability of our tools and, more importantly, to highlight for them just how big of a deal API security really is. So I work every day with a team of hackers, basically professional attackers, and in this talk, I'm going to talk a little bit about the experience and personality behind being an attacker, and I hope this gives you all some insights, as well as some insights about how to defend. So in this talk, we will be talking about your attackers, motivated, experienced pros and teams, the big enterprise and what it means for an attacker to be pitted against an enterprise. We'll review how attackers find weak spots, where do they start, and very importantly, one of the underlying themes that accompanies this entire arena is automation and how it changes everything. Towards the end of the presentation, we will overview the basic strategy an enterprise needs to undertake in order to defend itself, or at least to make life harder for attackers, focusing on API security, which is the #1 new attack vector. So really the rise of APIs as an attack vector and the growth of API security as an arena reminds me a lot of the emergence of cloud security and the necessary awareness that organizations needed to adapt to in order to adopt and not be just 100% vulnerable to attackers. So the first thing to understand about your attackers is, as I mentioned, the unrelenting rise of tech, of cybersecurity and cyber warfare. They've all given rise to what can broadly be classified as two different types of attackers. The first is what we call your opportunist fisherman. This is a type of attacker that uses well-known techniques and tools to sort of cast a net and see what vulnerabilities they can find on a particular organization, or more often on any organization. So this is the type of attacker that is looking for known vulnerabilities and is looking for a culprit. The second type we call the dedicated hunter, which is the situation where an attacker has decided they are targeting your organization specifically through whatever attack vectors they can find. This requires a lot more dedication and affords customized attacks targeting your logic, setup, team, and your particular issues. So the fisherman has a net and is trying to find what will come up in the net. The dedicated hunter has a target and will use any weapon necessary in order to beat the target. So the logic behind the opportunist fisherman is something along the lines of, we know so-and-so vulnerabilities exist. Let's scan and see if we can find a culprit that has this vulnerability and then exploit it. So for example, if you've ever been looking through your web server's logs, you will very often see requests that have a very repetitive pattern for known endpoints that signify vulnerabilities. So this includes very often known WordPress endpoints, for example, part of automatic reconnaissance scanners that are looking for deployments with known vulnerabilities. This is perhaps the best way to illustrate the mindset of the opportunistic fisherman. They're looking for known vulnerabilities. They start from an exploitable vulnerability and they look for targets. Scanning open ports, default credentials, exposed database connections, exposed secrets, and so on. The fisherman relies on techniques that are proven to work and look for a culprit which has not mitigated or defended themselves from this particular vector. One thing we remain aware of, as we see this theme accompany us through everything, is the use of automation. Software is eating the world, and this is true for cybersecurity as well. Technology has always been the difference maker on the battlefield, and even your household individual attacker today has at their access powerful open source and free and non-free tools scanning for exploits. So we have this type of attacker scanning for known vulnerabilities using automatic tools, taking advantage of common mistakes, taking advantage of vulnerabilities that have been recently disclosed, and aiming for low-hanging fruit. Some examples of such attackers include exposed ports, hunters attacking for exposed ports, the Log4j family of vulnerabilities that have received a lot of publicity recently, old WordPress installations. Such attackers might use commercial scanners, test for default admin passwords, and target old servers. The dedicated hunter is where it gets much worse. This is your professional, funded, often ex-military team who have a specific objective of breaking into your organization. They are dedicated to hunting you, prepared and researched. They leverage any type of attack. They are experienced, and likely they have more field experience than you do. This can be a nation-state actor. We're seeing a lot of this as geopolitical tensions have been flaring up recently. Cybersecurity is viewed as a milder form of geopolitical warfare, and so we gradually see more and more international conflict transition into the cyber arena. Cybersecurity warfare is maturing, becoming commercialized, funding is abundant, education and awareness are rising, experts are becoming professionals, and professionals are becoming companies. So these are teams, companies focusing on hacking your organization. At the enterprise level, the monetary amount of damage caused by a breach can justify a multiple man-month of effort, and there are many ways for attackers to win, be it remote code execution, denial of service, data leaks. So this is not your average individual who has heard of a vulnerability and are using a scanner to see if they can find a vulnerable organization. This is a team that has put a particular target enterprise within their scopes and are doing what they can to find a way to hack into this organization. So they're focused on a specific target, they're prepared, they cheat. This is an important thing to understand about attackers. They don't have any rules they need to abide by. The internet is still very much a wild west, and every weakness can be used against you. Often combination of different attack vectors can be forged together to create the entry path to breach an organization. They're clever, and they will continue until they win. You do not need necessarily to reach remote code execution. There are many different ways to damage an organization. So these people are best compared with military units rather than with amateur hackers. Let's talk a little bit about the way an attacker views the target, the way an attacker looks in an enterprise. So ostensibly, when I, as an attacker, am pitted against an enterprise, it might seem like a very difficult problem. The enterprise might have lots of employees, security products to defend them, security teams, QA teams to verify their code. They likely have internal processes like audits, hopefully code reviews, bug bounties, penetration tests, and so on. So it seems like it's just me, the attacker, against a giant organization. So how can I, as a lowly attacker, stand a chance against such an enterprise that has hundreds, thousands of employees that are dedicated to developing, maintaining, and testing their products, their teams? It seems like a very big problem, right? It's important to understand also that as an attacker, I'm rarely incentivized to go after a small business. We aim for enterprises with very deep pockets, right? These are the juicy targets. But when you think it through, the fight between an attacker and an enterprise is never one against everyone at the same time, right? So if we talk about the level of an individual endpoint or feature, there aren't really thousands of employees working on every single feature. For an individual feature, for an individual API endpoint or route, there are really maybe 3 people who usually touch it. It could be a developer, maybe 2 developers, maybe a team leader that reviewed it, maybe a security person who saw it if the organization is particularly diligent and if the defenders are lucky. So now our chances are much better. From a human perspective, it's one attacker against 2 or 3 defenders. And these 3 people have a lot more work than one individual feature to maintain. These are developers. They usually have a very big list of tasks that need to be delivered. For them, security usually comes after correctness, robustness, maintainability, performance. Hopefully security is in the top 5, but even then, are you as a developer sure you got it all right? And the truth is, you probably don't care that much. The defender as a developer is incentivized to do just enough to get the ticket approved, which almost certainly does not entail a 6-month-long security review for each individual endpoint. So the experienced attackers know that it's not even a one-to-one battle. We can spend all day trying to hack your API, and you can't spend all day defending it. So of course you have a SOC, NOC, DevSecOps, pen tester, and whatnot, but eventually one human mistake is enough for us to breach the organization. No less importantly, oftentimes we are attacking a developer that has left the organization a long time ago. Enterprises have developer churn and people leave and switch roles. The beautiful thing about code is that you write it once and it works forever, but once the maintainer has left, we're attacking code that has nobody in charge of it, nobody that the original writer might have left a long time ago. Maybe they live in Mexico now, and the unmaintained code remains as an attack vector for us as an attacker. So one single mistake is enough for us. If we find a single mistake, this is enough for us to win. Even an enterprise that has 1,000 developers, 10,000 endpoints, a single missing if or an improperly implemented authorization flow can give us the keys to the kingdom. So a chain or an enterprise is only as strong as its weakest link. And no matter how large it grows, this actually just makes it harder for them to make sure that they're defended on all sides. So we're gradually venturing into the psychology of an attacker and understanding, first of all, where the confidence comes from, right? So even if you pit me against the largest enterprise in the world, the more developers they have, the lower the average ability of an individual developer is to defend the endpoints under their jurisdiction. So at this point, I know it's just me against the weakest developer the company ever had, the one sleepy developer who hated his job and left 2 years ago and nobody ever really replaced him. And I'm not working alone, right? I have my team with me. As we mentioned, good attackers band together. So now it's a group of us attackers against one individual defender. So to recap, sophisticated attackers work in teams, use custom technology that often they develop themselves in order to have the advantage, are experienced, are motivated. So these aren't just script kiddies anymore. These are often nation-state actors or ex or paramilitary groups working commercially. In any field, expertise is highly rewarded, and tech is, of course, no different. You are likely aware of the high salaries that experts in narrow fields can commandeer, and the same is true for offensive API security for both individuals and companies. Compensation runs high, motivation runs high. The rewards are very attractive, right? There's no internet police. It is still the Wild West on the internet. So you may have heard recently, for example, about the Lapsus attackers, which received some publicity using extremely crude approaches where they just tried social engineering or bribery to get access to employee accounts. This goes to show you that even basic techniques can create great damage, right? If you read the reports, you'll see they publicized their actions and ended up in jail. So the ones that get caught are usually the amateurs, right? The first thing you want to do as an attacker is not end up in jail. Sophisticated attackers act at a higher level, but the combination of all attack vectors is best. So you use all techniques in parallel, you buy weaknesses off each other and so on. And combining attack vectors is something that any attacker will allow themselves to do. So from an attacker's perspective, maybe the most important thing to understand is that all organizations are very vulnerable. And from our perspective, we have the majority. We are the favorites to win. So due to all of the above, from an attacker's perspective, the odds are almost always on our side. Our experience at WIB brings a lot of empirical evidence to back up this intuition. Almost every enterprise is very vulnerable. At the API level, these vulnerabilities are discoverable externally and exploitable externally. As scanning tools improve, and we at WIB, we lead this, it becomes mostly a matter of how quickly will we find and exploit the vulnerability. So how do we begin to scan a target for weaknesses? Well, we look at third parties that they use. We look at anything open source that they're using. Very importantly, we look at known, or what can be referred to as one-day vulnerabilities. We're looking for simple security misconfigurations like a route with missing authentication, or an endpoint or an exposed database, or logical errors in the code, such as improperly configured authorization. So consider from an attacker's point of view that it is not even necessarily that difficult to test for each of these. It's mostly a matter of knowledge of what you're looking for. So to focus on the Ebola vulnerability, which is maybe the #1 vulnerability in terms of API security. This is when one authenticated user can access resources that belong to other authenticated users. So this is a problem with the authorization of authenticated users that allows me to access your data as another user in the company. This is a very common attack that can't be blocked by existing traditional cloud security tools such as WAFs, is trivial to test for, and has company destroying damage if it exists. Consider a financial institution which has this vulnerability. It's a case of a simple missing if in the code, can lead one user again to access the financial data of another user, renders the entire company extremely vulnerable. This particular vulnerability has been seen recently in places such as PayPal, Uber, Coinbase, and the impact on the organization can be immense. We focus a lot on the APIs, right? As everyone in this conference is obviously aware, APIs are just a tremendous attack vector from an attacker's perspective, just a direct line into the database. You know, it's like an attacker asks themselves, how are we going to get to the crown jewels of the organization? Well, it's fantastic. They wrote a route that I can just query using HTTP and pull the data that I want. So this is really rolling out the red carpet for attackers. It is interesting to focus, and we remind you that since most of the time we are black box testing, since we don't have, as an attacker, visibility into the code that we're attacking, that most attacking is guided by an intuitive experience of reverse engineering of how the code base likely works. Understanding the way a code works obviously helps you a lot to attack it, and vice versa. This is why there is a lot of overlap in cybersecurity between defensive and offensive experience, and API security is perhaps an excellent showcase of this phenomenon. So a lot of teams and individuals do both, or rely on experience from offense to help their defense, or vice versa. Really, the best way to learn offense, you see a lot of people trying to get into the cybersecurity field and learn how to be a better attacker. One of the best ways to learn offense is to implement a lot of defense, and of course, vice versa. I see some questions in the chat. Let's see, devs were specifically picked out as a weak link. Edwin Hurst asks, devs were specifically picked out as a weak link. What should we be doing to raise the level there? Well, that's an excellent question. We'll talk about that a little bit later. Maybe the best title for this approach is referred to as shift left, which is making sure developers share the responsibility for security and implement secure code as early as possible. So to shift the responsibility of security as early as possible into the development chain. And there are tools to help this, to help either encourage developers to write code securely or use frameworks that are more secure, and more importantly, to audit the code as early as possible in the development phase. We'll be talking about some tools that can do this in a little bit. To continue a little bit now on how an attacker might be scoping out an enterprise for weaknesses. And I do want to say that developers aren't really targeted as a weak link as much as they are the star of the show, right? The whole thing, we're talking about code, about software. Developers are the ones running the ship. So if anything goes wrong, it's on their shoulders. Everything that goes right is also on their shoulders. It's a lot of responsibility, and it's a very difficult task to be a developer, and it is significantly more difficult once this is not an individual developer, but teams of development. Software development is a very hard task, and security is one of the many things that are hard to get right, and that if you get them wrong once, then the entire company can be totaled. So an attacker looking to total a company by finding the breach usually starts with the client side, right? Since most consumer-facing organizations have some client application, either a mobile app or a web application or some sort of smart device, the API communication between the client and server is the first vector, which gives us a map of potential attack vectors, as well as the business logic for what are we looking at and what are we looking for and what are we thinking we can do to hurt the organization, right? So if it's a health organization, we might be trying to filter out private data of users. If it's a financial organization, we might be looking to get either private data or to trick it into passing funds incorrectly and so on. So it's important for an attacker to first of all understand the business logic, and then find where this business logic is being applied within the app at the technical level, right? So it's important to understand here that usually when we're trying to attack an enterprise, we're not even necessarily looking for a specific objective. We're not looking for a specific flag to capture as much as usually just an attempt to cause damage. This makes our job as an attacker 1,000 times easier. There are many, many, many ways to win. So some examples might include anything around the authentication logic, right? If there's any way we can bypass either the sign up, login, or forgot password and reach an account takeover, this means all the user data is exposed. And we see anything around authentication is an extremely vulnerable point of the application and very hard to get right. If there's a problem with the authorization, as we discussed earlier, this also means I, as a user, can access another user's data. This means I can access all users' data, which means all user data is exposed, almost as bad as it can get. Using the client application, we start by scoping out all the APIs. This gives us the server attack surface. We know now what we can attack, all, or at least some of the vectors to attack the server. We check for client-side injection options, and this is starting, once we're speaking this language, we've started the attack, right? Where we've scoped out the most basic and the obvious places to start looking for vulnerabilities. This stage is known often as reconnaissance, right? And what we do here is we map, the first thing we do is we map the API of the target, all the routes, figure out what headers are being sent, each header, what it means, all parameters. We try every single route. We see if there's a route that responds without authentication or that reacts poorly to misconfigured input. We map the network traffic to gather as much information about the server as possible, really not leaving a stone unturned. Again, automation is the game changer because this process, this know-how and experience, which has been honed over the last few years, has matured into automatic tools, some of them commercially available and some proprietary, that really just render this entire process to be an automatic and immediate. So it gradually evolves. The cyber warfare, especially around API security, has evolved from a clash of experts to clash of technologies, because experts codify and formalize the abilities into automatic tools that just do all this at the click of a button, which of course gives attackers now more sophisticated tools which they can use better. From a defender's point of view, it's very important to be able to stop attackers at the reconnaissance phase, because, well, this should be obvious, but you really want to prevent your adversary from even collecting the information about you, which would make it able for them to launch an attack and use an exploit. Let's talk about some well-known attacks, at least briefly. First strategy that attackers often use is called fuzzing. This is when you look at a request, you see what parameters are being sent. You see, for example, the sign-up flow sends an email. Let's see what happens if we change the type of the parameter from an email to a non-email string. Let's see if the server might throw an error on this. Maybe they're parsing around the @ sign and they crash if there's no @ sign. Of course, this is done at the API level, so it bypasses any client validations. We not only check to see what happens if it's not an email, let's see what happens and how the server responds if we send an array, an empty string, a null, an object, a file, and so on and so forth. We check this for every parameter, for every type, for every route. Why not? It's automatic. Just flip the switch. If you have a sophisticated enough tool like Wib's Attack Simulator, this whole process just happens automatically. And this helps you check that every developer on every endpoint wrote the correct validation for every type of data. And if not, we might get an error, which is a good starting point for any attacker to scope out how the server responds to errors and get further intel to move ahead and search for an exploitable breach. Second type of attack, well-known cross-site scripting, is when we inject code that might run on another user's browser and might help us either deface the site or steal a session or do similar damage. Another type of attack, cross-site request forgery, which lets us forge a request on behalf of a victim user. Another type of attack is traffic-based denial of service, which relies on a server not implementing correct rate limiting, which allows us to, and this is, so traffic-based denial of service is an example of attack which is very loud because the victim will notice it, but requires active defense. So even if you write your API perfectly without making any mistakes, the server is still by default not defended against a denial of service attack, which is basically just sending a million requests to the server at once. So a server needs to implement some layer to defend against a denial of service attack. Otherwise, by default, they are vulnerable to it. Another type of attack is traffic-based distributed denial of service, which would rely on a system of a network of malicious computers all attacking the target at once. So this is even harder to defend against, and it gets even more harder if the more sophisticated the DDoS is. For example, by using a low and slow attack where all the malicious computers do not attack with full force, but rather with just enough to crash the server, but not set off any alarm bells. So the more sophisticated the attacks get, the more sophisticated the defense needs to get, and it's an arms race, but attackers always have the advantage because it's enough for them to score once, while the defense needs to maintain a perfect track record. And the list goes on. There are many types of attacks. We will just name them. You can, as an attacker, I'm looking for routes that are missing authentication at all. I'm looking for authentication where I can guess the credentials, be it at login or at some sort of a header which supplies the authentication. I can try to brute force the authentication if there's not insufficient rate limiting around it. We have seen many attacks where, especially flows such as confirm your forgotten password via a 4-digit PIN, you could brute force it. We're looking for Ebola vulnerabilities where I can access other users' data. We're trying resource-based denial of service, which is where we create resources that are large enough that trying to fetch them, or a list of resources that trying to fetch all of them naively might crash. Sub-resource-based denial of service, which is where a resource, we can create many sub-resources and try to fetch all of them at once and see if they fail. We have injections, SQL injections, NoSQL injections. We have remote code vulnerabilities on known one-day vulnerability stacks. We have supply chain attacks. We have timing attacks. We have social engineering attacks, homograph attacks, tab nabbing. So the list goes on, right? There's a lot of possible attacks, and attackers gradually are able to launch each of them automatically. How is the defense going to implement all the necessary defensive measures to stop every single one of these attacks? My money is on that they're not going to be able to stop all attacks, which is why we are the favorites as attackers. So what's important to understand is that there are many of known attack vectors, and with time, more and more of these attack vectors can be executed automatically. From a defender's point of view, each such attack requires a specialized active defensive measure to counteract it. So this turns into sort of a judo match where we try and attack and see if it was properly blocked. The list is long, and security defenses are, as we discussed, not the #1 priority. Has a defense set up a counter move for each one of these attacks? Have they tested it? Usually the answer is no. Relying on automation, checking each one of these attacks gradually becomes less work for the attacker, and we can test more and more attack scenarios automatically. The savvy attacker team does not even need to be aware of how each technique works because automated attack simulators do this more and more for you. At WIB, the team I lead is building an attack simulator, which is probably a couple of years ahead of the market. And as I mentioned, attackers like us are playing to win, and tech is a difference maker. So we build our own tools to make this reconnaissance faster. This makes cybersecurity defense even harder as it becomes an arms race. So one-day vulnerabilities are one very, very common attack vector where any error from the server is often returned with just the default error handler, which often includes information about the server type and version number. So imagine just your standard server that hasn't been upgraded in a while and the community has found vulnerabilities in it. And when we ping a route with some malicious input that doesn't necessarily break the server but triggers an error, if it's the default error handler, it returns the server version, we can automatically cross-reference the server version with the known list of vulnerabilities on this particular server, and just get the actual vulnerabilities that exist on the target. So this gives us an immediate quick step forward in terms of finding exploitable breaches on the target, and sad to say is very, very, very common as we see it with almost every enterprise. Additional vectors we try just are cross-site scripting, SQL injection, no SQL injection, CSRF, authentication attacks, and again with automation, all of this happens very quickly. One pattern that we see often is a Ebola data leak, especially coupled with a lack of rate limiting. So imagine you have this pattern in terms of your API routes where the order number is part of the URL, and you have a Ebola vulnerability where one user is able to access another user's orders. This opens up the organization to an enumeration attack. Coupled with Ebola, coupled with lack of rate limiting, we can write a script to simply iterate over all of the numbers and pull all of the files back home. The end effect is the same as if the database was leaked, and this is just a very tragic vulnerability from the enterprise's point of view. The same way, let's talk about edge cases, something attackers always do. So the same way QA testers check edge cases to see how the software will respond, so do penetration testers and attackers. The golden path assumed by the developer of how people are going to use the API is quickly left behind, and we explore just how each part of the system will respond to all kinds of exotic inputs. A while ago, there was a YouTube show called Will It Blend, where random items were tested in a blender to see if they would, well, blend. Similarly, API attackers test Will It Bend, which is to test just how an API endpoint and the entire stack supporting it will hold under various kinds of stress. The point is, to quote Joel Spolsky, all abstractions are leaky. Under enough pressure, every endpoint will start acting up. It's just up to the attacker to eventually find the right unexpected use case, which makes the server react in an unexpected way. So on the screen, you can see an example where if we have a route that accepts a payload, let's see what happens if the payload is 100,000 characters long. What happens if it's 1 million characters long? What happens if it's 30 million characters long? Will it work? How long will the server take to respond? It's enough for an endpoint to act poorly to large input and take very long time to response for us to craft this into a denial of service attack by executing a few dozen of such requests in parallel. No server is invincible and has endless capacity. Every resource can be manipulated. So if users can add a link, we can try to inject code by supplying a link with an unexpected format, such as a data text. If a route, an API route, accepts file uploads, we check what happens if we upload a zip bomb, or what happens if we just upload a giant file, or upload a Trojan horse, or use the file upload endpoint to stage a DDoS by having 100 different servers upload files endlessly and jam the server. If we can detect that the target server is using a background service, such as something for geolocations or to handle emails or file uploads, we can target that specific route because we know it is relying on an external service which might crash or deny further service if it is subject to too much load. If we get stuck, it does happen, at least in theory, that we're looking at a domain and we haven't found any vulnerable endpoints in it. What we do is we move laterally. It is very easy to find the additional subdomains of an enterprise that are exposed to the internet. This is the API equivalent of a lateral movement between servers. And we can simply jump between different subdomains until we do find a subdomain that is vulnerable. As enterprises host more and more services and expose more and more domains, over time they even lose track of all of the domains that they're exposing, and any one of these can be a vulnerability into the enterprise. We see this very often where by searching for subdomains, we find a subdomain that seemingly the enterprise has forgotten about, but still includes endpoints that are vulnerable. Very dangerous vector, one that should be high on the mind of defenders. We will now talk about a specific attack that we launched against one of our clients called Smart Home. It's not their real name because I Googled and there happens to be a company called Smart Home. It's not them. What we did with Smart Home was we tried to attack them through their API. So we started by attacking all the API endpoints. And we found one endpoint that when we submitted an invalid character, so like a special character as part of the payload, it crashed. and this crash returned an uncensored error message of the type that we saw earlier. This error message included the background stack, which revealed an internal service which was exposed on another subdomain. So we started with one API route, through an invalid input, got an uncensored error message, which included the details of an exposed subdomain. This exposed subdomain had yet another API vulnerability in it, which allowed us to forge emails on behalf of the company. So to trigger an internal email that was sent through an internal email address. So it appears to be a very valid internal email to the people who are receiving it. So we sent a forged email to people within the company, and in the email we directed them to a phishing portal, which we set up on a domain which we used in IDN homograph attack. So the domain had the same name of the client, except one of the characters was visually identical, but actually used a different Unicode encoding. So here the A with a small circle over it just to illustrate what we're doing, but in the actual attack case, the A was visually identical, but used a different Unicode encryption. This is an IDN homograph attack on a domain, not part of API security, but as we mentioned, IDN homograph attacks, phishing attacks, combined with API security, attackers don't care. They're not trying to win. They're not trying to get a good score on an essay. They're trying to break into the organization, so everything goes. So we set up this fake phishing portal, sent the internal email from an internal address to the CISO of the company, asking him to log into the portal. Once he tries to log in, of course, we have a keylogger, and now we get the CISO's credentials, and now we're really deep inside the organization. So this is the sort of long and detailed attack that a sophisticated team that is bent on penetrating a specific organization might launch. It's more than just relying on some vulnerability that was found in the news. It is a customized, personalized attack against this organization. It is very hard to defend all possible vectors. And as attackers, we know this, and this gives us a lot of confidence. The moral of this story is that attackers are persistent, creative, and they will do whatever it takes. Another example of one of our clients, Proto Lola, is a travel agency that exactly had the Ebola and enumeration and lack of rate limiting that we saw earlier that allowed us to just enumerate and pull all of the clients' passports and bank details and just all of their documents. And you can imagine the amount of damage that this can cause an organization. Most importantly, we can do all of this automatically. So now attackers are gradually getting the ability to automatically scan your API, attack it, and if you have any logical bugs in the code or missing defenses, download all of your user data. This happens automatically, it happens fast. Computer viruses have always been weaponized, and now they're coming at your APIs. And if you don't have something to defend you, it is very difficult to imagine that attackers will not be able to enter the organization. So the opportunist attacker that we described earlier, the fisherman, can be stopped if you follow best security practices. But the dedicated hunter is hard to stop. They are stubborn, they're patient, they're autodidact, and they're highly motivated to hurt us. Gartner marks API attacks as the #1 vector, right? What can we do to defend? If we have the main takeaways in order to defend ourselves are to check potential threats right from the beginning, stop even people doing reconnaissance, shift left, make sure the code is secure as early as possible. And maybe most importantly is that defenders need to have the appropriate technology to be able to meet attackers, right? This was true on the battlefield, and it's true on the cyber battlefield as well. So companies need a full lifecycle API security solution, and this includes 3 main technological tenets. The first one is a code analysis solution. This is the part of shift left that is relevant for API security. This is an ability to analyze the API at the code level and find any vulnerabilities before they reach production. Second tenet is running an attack simulation. Use the best tech you can find on the market to pretend attackers are attacking you and find all of your vulnerabilities before they do. Treat attacks against you as something that is happening right now. Assume you are under attack and find all these vulnerabilities before you get on someone's radar and they find it for you. And the third aspect is to have some sort of internal firewall equivalent for the API world. This is referred to as traffic inspection in the API security scene, where you want to have an internal tool that analyzes all the incoming traffic and knows how to detect requests that are malicious, that are part of an attack. The details on how such a tool works are for another time, for another talk, but these are the three main tenets that a diligent security team should apply to an enterprise to make sure that they are doing whatever they can to defend at least against API security attacks. So thank you very much for attending this talk. We have 10 more minutes. Let's see if we have questions from the audience. This would be a good time to answer them. So Edwin asks, how long did this attack take? Hours, days, weeks, or more? I assume you are referring to the attack we launched against Smart Home. It took a while. It took a while. When you launch such an attack, there are a few factors you want to take into consideration that are not just technical, right? So you're actually playing the human factor. Once you're involved with actual interaction with the victim, with the target, then there are human factors you're taking into consideration, especially if you're doing something like phishing and you need to do it gently, and it's not just a matter of force. So some parts can be automated and some parts rely on a human factor that might be a little bit slower. Another question by Richard Glassman. Are companies implementing Center of Excellence for white hat hacking? Many companies are realizing the importance of treating offensive measures as a core part of a security strategy. So not just setting up a defense, but having the best attackers they can find, attack them, to assume the worst and find your vulnerabilities before the malicious attackers do. So we have just a few minutes left, and I'll just review again the core components of a full lifecycle API security strategy, which are code analysis, the development part of your API lifecycle to make sure APIs are being developed in a secure fashion. Attack simulation is part of your testing strategy, both before and in production, to make sure that you are aware of all your vulnerabilities and you find them before the opposition. And traffic inspection to make sure your production is defended the same way firewalls became a thing for defending ports and traffic. We need an API security specific solution to make sure that your API requests are being monitored and that attacks are singled out and blocked. We do have another question in the audience. What are your recommended tools in hacking an API? My recommendation is Wib's Attack Simulator. This is a tool that is probably a couple years ahead of the rest of the market and is the most powerful API attack simulator that exists in the world today, certainly in the market at least. And this is a tool that attackers are developing, and it is recommended for any security team to use such tools to find their vulnerabilities before the opposition. So thank you very much, everyone, for attending this talk, and we look forward to being in touch, and please feel encouraged to write me with your comments. Thank you, everyone. Have a great day, and we'll see you on the next talks.